So I'm going to be doing this. I wouldn't say often, but every once in a while. Where if there's an example in the book that I think is particularly readable, it's important that you learn that a book is a useful tool. And because you guys don't have books that you take home necessarily, you could if you wanted to. They have copies in the finance office. Are they out?
They have them?
Yeah, no, they should have some, but they don't have enough for all. That's the difference. Yeah, so I love TOC for that. Thank you, TOC. But they, it's important that you understand that a book is actually a really useful tool. And believe it or not, I read the books so that I can teach you. All right, so you could do that also. All right, here we go. Today's kind of an easy day. We want to be able to calculate the distance and the midpoint between 2 points. So first, what is the distance formula? Big giant square root. It's in the book.
x2 minus x1 over.
Oh.
No.
Plus.
x1.
X2 minus x1.
Squared. Y squared.
Y2 minus
y1 squared. Okay. All right, ladies and gentlemen. Guess what? You need to memorize that.
Oh, I remember it now.
Okay. And then you also need to know the midpoint formula. The midpoint formula is an ordered pair. It is the midpoint between two other points, the midpoint of a line, or rather a line segment. The midpoint, also known as the middle. Middle is another word for average. If you want to find an ordered pair, that is the midpoint or the average point. How do you find an average? You add and divide, right? Okay. So if we want to have an average point, we're going to take the x values, x1 and x2, and we're going to do what? Add them. And then divide by 2, because that is an average. Add them together and divide by 2. We're going to do the same with the y values, y1 plus y2, and divide by 2. Ladies and gentlemen, this is another thing you need to know. Is it something you have to memorize?
Yes.
Maybe. I don't, because I understand that the midpoint is an average. It's the average of the x's, the average of the x coordinates, and the average of the y coordinates. I don't have to memorize anything because I know that that's a middle. Okay? So the common mistakes with these formulas is that everyone puts pluses everywhere or everyone puts minuses everywhere. We're subtracting to find the length here. And here we're taking an average, which is adding. Okay, so be very, very careful. We will get back to that, but first we get to do some graphing. Example 1, determine the quadrants. Quadrants, the parentheses F, which means it could be 1 quadrant or 2 quadrants. Determine the quadrants in which XY is located. Determine the quadrants in which XY is located so that the conditions are satisfied. Determine the quadrants in which XY is located so that the conditions are satisfied. All right, here we go. We have a couple of conditions here. So in letter A, I have the condition that x is equal to -3 and y is less than 0. What we're trying to figure out is where is this a point located. All right, and it's a very generic point. So first of all, really quickly here, let's review. What is this quadrant's name? Left quadrant, upper left. Yeah, quadrant 2. Where's quadrant 1? Top up right. There we go. Okay. Quadrant 1, quadrant 2. What's down here?
Quadrant 3.
And over here.
Quadrant 4.
Okay. Did you ever wonder why it goes like this?
Why?
It's because of trigonometry.
Does that have anything to do with the negatives?
No, it has to do with trig. All the trig. Trig came first.
I stare.
Okay. All right. So here's what I'm going to do. The first thing I'm going to look at is I'm going to say, all right, I have a condition. And the condition here is that x is equal to -3. If x is equal to -3, what quadrants am I in?
2 and 3.
2 and 3, right? Because -1, -2. Right here is where x is equal to -3. Which means I could have a point up here. And maybe generically, what could I name this point if it was right there? -3, comma 4? Okay, sure. And what about this point right here? What might that be? -3, comma 2. -2, right? Yeah, okay. So right now we're in quadrant 2 or 3. All right. But now we have another condition to satisfy. We need the condition that the y values must be less than 0. So looking at this ordered pair that we just sort of made up, is that y value less than 0? No. What about this one? Yes. All right, here we have a y value less than 0 because we're here in negative y land where all the y values are less than 0. So what quadrant is our point in? Quadrant 3. So xy must be in quadrant 3. So I like assigning, when they give us like generic information, just like, I like using numbers because when you use numbers, a lot of things become clear. All right. So letter B here, got a couple of generic statements, but again, I like to draw a picture. And maybe you can reason through this stuff in your head, okay? But I'm a teacher, it's what I do. I'm going to walk you through everything, all right?
Thank you.
Yeah, you're so welcome. All right. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And because all they gave me are some really generic things, I'm going to go ahead and just pick some random points. And you're just going to give me, approximate numbers here. Let's try like this point. What might this point in quadrant 1 be labeled? A1. Okay, great. And what might this point be labeled?
-3, 5.
I heard -2. I'll go with the 5. Okay. And then what might, I don't know, this point be labeled? Okay, I heard -6, -4. That works. And then, what about this point? What might that point be? 2, -1. Okay, perfect. Okay, so I picked some random points. And really, that's just so we can, they're not to scale, but I label them, so that's what they are. Okay? That's the rule in my class. You label it. I don't care what the tick marks are.
Good.
Plot it, label it. Done. Okay? All right. So now that I have that, I want to go through these conditions. So my first condition here is that x is greater than 0. And since I've got some points, some test points, here. Is this x value greater than 0?
Yes.
Yes, okay, that works. Is this x value greater than 0? No, x is not greater than 0, so that doesn't work. Is this x greater than 0? No. Is this x greater than 0?
Yes.
Yes, x is greater than 0. Why? Because we're here where all the x's are greater than 0. Everything to the right of the origin in quadrant 1 and quadrant 4 all of our x values are greater than 0. Now, I want to go to this other condition. What does that mean?
Y is less than 0.
Okay, so y is less than 0. That's really good. I want to read it like this, though, because I really want you to understand what this says. A lot of students will say just negative y is greater than 0, and that's just kind of a weird statement. So whenever I see a negative, I'm actually thinking the opposite of my y is greater than 0. And so, yes, you're right. You can divide through by the negative. You could do that. But I want to read that just to show you what happens here. If this is my y value, then I can just sort of plug it in. The opposite of my y value is greater than 0. Is that a true or false statement?
True.
The opposite of 1 is greater than 0. Negative.
Oh.
Yeah, that's false. Okay, but then when I go to this one, the opposite of my y value is greater than 0. What's the opposite of my y value? Positive 1. Is that greater than 0? Yeah, so this is a true statement. So what quadrant do we wind up in? Quadrant 4. So there's a lot of ways that you can go through this. You can talk through it, but you know, I am not good at X's and Y's. Like I'm not good like that. I'm much better just testing numbers. All right, for me that works. All right, but there's lots of ways to do it. I'm always going to go back to numbers to prove it to myself. All right, hopefully you got that. Last one. Example 2, plot the point. Find the distance, find the midpoint.
Are we going to get graph paper for this?
No.
Not for this.
I'm just paying.
Because you really don't need graph paper, because what did I just say? You plot the point, you label it. Good. I don't need to take marks.
You're right.
Just put it in the general locale, you're good to go.
Sure.
All right. Plot the points. Find the distance between. Find the midpoint. You guys have lots of fractions in your homework.
Very cool.
But you have calculators. Well, classwork. You guys have calculators. You shouldn't find that scary at all. All right. Find the distance between. Find the midpoint. Okay. So first, I'm going to plot these points. Again, you do not need graph paper because randomly, -1, -4 is somewhere down here in quadrant 3. That's all you need to do. Plot it, label it. You do not need tick marks. Put it in quadrant 3, approximately where it would belong, and label it, and that is what it is. No one can argue against you, okay? 3, 2. Plot it, label it, and that's it. So this is we want to find the distance between the points and find the midpoint of the line segment. So first I'm going to do big D here. Big D, big giant square root. All right, what are we subtracting? The x's. Subtract the x's. 3 minus a -1 or +1. Good. Quantity squared plus 2 minus the -4 quantity squared, which of course you know is plus. All right. This is just a formula. Hopefully you saw that a long time ago. This becomes 4. Being squared is always 16. This number is being squared. Should you ever get a negative result? No, you should not. All right. Here, this becomes 6, and we square it, we get 36. Is the square root of 6 plus 36 equal to 4 plus 6, which is 10? No, God, no. Do not do that. No. Okay. So many people love to do that. It ain't right. Okay, so that is radical 52. And then what do we need to do to this radical 52? Simplify. 52 is 4 times 13. What's the square root of 4? 2. Radical 13. A lot of people miss that on their tests. Simplifying radicals was hard. Ladies and gentlemen, when I have a radical, I will always simplify the radicals. So my answer choices on like a test would always be like 2 radical 13 or 2 radical 15 or something like that. Maybe you used your calculator and you just put in radical 52 and you got a decimal approximation. How would you know that your answer matched my A, B, C, or D? Can plug them in. Can you plug in my answers and approximate them? Of course you can. Of course you can. You are absolutely always allowed to do that. Okay. Midpoint. What is a midpoint? What does it really mean? The average. Thank you. The average. We're going to take the average of the x values. What's an average? Add and divide, right? So we're going to add our x values. So -1 plus 3 and divide by 2. And we're going to add our y values. -4 plus 2 divided by 2. You can notice that even just looking at my little segment that connects my points, I was going to guess like right there, if I had to pick the midpoint, that looks like it bisects the segment, roughly. And certainly -1 plus 3 is 2, over 2 is 1. -4 plus 2 is -2, over 2 is -1. So that makes perfect sense that that midpoint is 1, 1. All right. I'm sorry, 1, -1. Thank you. 1, -1. All right. So you can certainly use the formulas, but I want to point out that the distance formula is annoying and I hate it. And I never use it. I never use the distance formula because when I look at this picture, I see a triangle.
What? Oh, no, I see. That's a line.
Do you see a triangle?
Oh, right in the middle.
Do you see a base?
Yes.
Do you see a height?
Yes. Wow.
All right.
Oh, is this?
So guess where the distance formula comes from?
Oh my gosh, it's like collecting stuff in his head.
Pythagorean theorem.
I call it the hypotenuse theorem. The hypotenuse.
All right.
45, 90 right there.
Well, no, but it's the Pythagorean theorem. So when I look at this, I'm finding the length of this base, which you can just count because I have a nice graph. It's 4. But if I didn't have a nice graph, if I wanted to find that length of that base segment, I would subtract my x values. The distance between -1 and 3 is 4 units, which you can think through or you can subtract to get a distance. It's the absolute value because distances are always positive. So the same thing is true for this side. The height here, I could just count and it's 6, but that 6 comes by looking at the space between the y coordinates. So to go from -4 all the way to 2 is a distance of 6. 2 minus a -4 is 6. So the distance formula is just the Pythagorean theorem when you think through that. This would be 4 squared plus 6 squared, which is 16 plus 36. There's our 4, there's our 6. So 16 plus 36 is 52. And then how do you get the hypotenuse by itself? You square root. There's our radical 52, which simplifies to 2 radical 13. This is where this comes from. Ladies and gentlemen, this is all second semester. Pythagorean theorem. Over and over and over again. Okay.
Wouldn't it be equal plus or minus?
True. So Nellie just said, when you take a square root, don't you have to remember plus or minus? And you're absolutely right.
Good job.
But this is geometry. Can you have a negative distance? No. Yeah. So we just take the positive. But you are right. Algebraically speaking, you would need a plus or minus. But we can ignore the negative because it's a real length. All right.
It's like 24.
I counted. 1, 2, 3.
Well, I don't know if you would. We're not
Or
gonna
subtract.
Okay.
All right, ladies and gentlemen, you may begin.
I think that's for point, you said like it doesn't have to be like